following the earlier discovery that the two 20-watt lights above my bench, the one with the 50-watt LED in it was actually putting out more light than the one with the 20-watt LED, the one with more chips that was being basically underdriven. I decided to do a wee test. I got this light fitting with the 10-watt LED in it, temporarily removed the driver, and I just hot-wired it to a couple of leads, and I've got it on the bench power supply with the current being limited. So I'm just placing this over this light meter, which I've got a couple of support pillars, Wago boxes, which were just the right height. Centered that up, and then by varying the current, the intensity would vary, and I'd be able to measure the output in lux. That's lux, that's hundreds of lux it's currently set to, and I charted it off. And interestingly, one of the first interesting features here was that as soon as you get to exactly 1 amp, the LED's forward voltage was 9.99 volts, which means exactly 10 watts at 1 amp. But anyway, I shall turn that off at the moment, move these out the way, and show you the results. Turn my little meter off. The results were that at 100 milliamps, the voltage across the LEDs was 7.95 volts, and that varied almost linearly with the current. And the watts were also fairly linear. The intensity was a bit odd. Initially, I can show you, I've charted these down, but I also put them into a graph generator. So I'll move that out the way, and I'll show you. This was a power versus current, and it's pretty much a near linear line. Likewise, LED voltage versus current, we sort of wobble at the front, but then it went up quite quickly. And then the LED efficiency, and it's really odd, I kind of expected this line to go right up. I really did expect that line to just sort of continue up like that, but it didn't. It kind of like it started at a lower efficiency, and I was just trying to work that out, because the peak of efficiency happened if the normal operating current is about 900 milliamps to an amp. The actual peak of efficiency happened at 200 milliamps, and I was almost expecting it, based on the sort of readings, I was expecting that to happen at 100 milliamps. So I took another look at the light, the LED, and I wondered, is there something, maybe there's a duff LED chip in this or something that's maybe skewing the result. So here's a light filter I'll put over the LED, and I'll hold it up so you can see it. And I shall turn the output on. Oh, dazzling. And when you turn the current up really slowly, I'm not sure if you'll see this, but only 2 LEDs out the whole array of 9 LEDs have lit. Now these are a 3x3 array. There are 3 in series, and it just so happens that in that one, I'll doodle it down in fact. Inside here are 1, 2, 3, 4, 5, 6, 7, 8, 9 chips, and they're effectively wired in series, and then they're all commed at one end and all commed at the other end. Power's applied across them, and if they're all matched they should light, but this one is a duffer. It does light. It lights when I get, at the moment there's only 2 in there lit, but as I turn the current up, all the others start lighting even though there are still only 2 lit. And the 2 on their own, these 2 here, are much brighter than the others, and as I turn it up even further, when I get to 300 milliamps, that rogue one starts to glow, but I don't think it's ever going to actually be as efficient as the others, so that has potentially skewed my results, which is a bit annoying, having charted it all out like that. And suddenly I'm also realising that maybe that's why that LED was specifically chosen for the fixture that they put out as a 10-watt one, but at a 3-watt driver. Maybe they paired the 3-watt drivers with the duff LEDs. so they last a wee bit longer than they normally would, because that would die quite quickly on a 10 watt, full 10 watt driver. So that's even tackier of them to do that. So yes, I think I'm going to have to redo that test with a LED that I carefully test beforehand.